Welcome to this lesson on electromagnetic spectrum. So, this topic, we are going to describe the complete electromagnetic spectrum, state the properties of electromagnetic waves, describe methods of detecting electromagnetic radiations, and end it by solving few numerical problems involving the formula C equals to F. What is electromagnetic spectrum? This is the arrangement of the electromagnetic waves according to their frequencies or wavelengths. Now, this video will illustrate on what electromagnetic waves are.
What do all these activities have in common? Each of them use waves from the electromagnetic spectrum. The electromagnetic spectrum is composed of EM waves. These are waves that are created as a result of vibrations between an electric field and a magnetic field. In other words, EM waves are composed of oscillating magnetic and electric fields. This is why they are called electromagnetic waves. The electric field and the magnetic field of an electromagnetic wave are perpendicular or right angles to each other, and they're also perpendicular to the direction or propagation of the wave. The electromagnetic spectrum is ordered by frequency, which is the number of wavelengths that pass a fixed point per second. Frequency is measured in hertz, and the spectrum has a very wide range from 300 kilohertz to an incredibly small 3 times 10 to the 21st power hertz. An electromagnetic wave can travel through anything like air, solid material, or even vacuum. It does not need a medium to propagate or travel from one place to another. Electromagnetic waves can even travel through the vacuum of outer space. Let's take a look at the electromagnetic spectrum. Radio waves have a very low frequency, and they have a wavelength roughly the size of a soccer field. Moving to the right are microwaves, and they have wavelengths roughly the size of a baseball. In the middle is visible light, with a wavelength the size of bacteria. Visible light can be subdivided by color, with red having the lowest frequency and blue having the highest frequency. Now, at this point, the wavelengths are very, very small. X-rays are slightly larger than a water molecule, and radioactive sources, such as gamma rays, are the size of atoms. The electromagnetic spectrum is used in everyday life, from listening to music, to visible light, to microwave ovens, to even looking inside our bodies. If you'd like to know more about the electromagnetic...
Thank you. So, the electromagnetic waves are just transverse waves which result from oscillating electric and magnetic fields at right angle to each other. So examples include, for example, if we arrange them in order of increasing wavelength, we start with gamma, then we have the X-rays, UV light, visible light, infrared, microwaves, and finally the radio waves, which have the longest wavelengths. So there you can use the acronym GACSUVIMRA, but if you arrange them in order of increasing frequency, you have radio waves, microwaves, infrared, then visible light, then we have the UV light, X-rays, and lastly gamma. So you can talk of Rami-Voxga. What are some of the properties of electromagnetic waves? One, they are transverse in nature. They also do not require any material medium for transmission. They travel through space at speed of light. They carry no charge, hence not affected by electric or magnetic fields. They undergo interference, reflection, diffraction, refraction, and polarization effect. They possess energy in different amounts according to the equation E equals to hf, where h is the Planck's constant and E is the energy, f is the frequency. So Planck's constant is just 6.63 times 10 raised to the power negative 34 joules second. They also obey the wave equation C equals to. Well, you can try that question based on the formulas that you have just stated. How are these waves produced? One, we'll start by looking at the radio waves, whereby radio waves are produced by oscillating electrical circuits and are transmitted through aerials or antenna. So they are detected by the diodes and the earphones. You also have the microwaves. These are just special vacuum tubes called magnetrons in microwave ovens or with a massa. And they are detected by dry crystal detectors or solid state diodes. Infrared radiations, the sun source is the sun or any hot body. So they are detected by the skin through heating effect. We have the thermopile bolometer and thermometer with blackened. UV light is the source is the sun. We also have the sparks and also mercury vapor lamps detected by photographic films, the photocells, fluorescent materials like quinine sulfate, and paper lightly smeared with Vaseline. We also have X-rays. So this is where we have action of beam of fast-moving electrons hitting a metal target. So they're detected using fluorescent screen or photographic film. Then lastly, we have the gamma rays, whose source is majorly the radioactive substances like uranium and are majorly detected by radiation detectors like the Geiger-Müller tube photographic plate, and also we talk of the cloud chambers, that is diffusion cloud chamber and the expansion. Now, are these waves important in day-to-day life? Yes. For instance, the gamma rays, which has the highest frequencies used in field of medicine to kill cancerous tissues and also used to sterilize the surgical or medical equipments. They are also used to sterilize the pests. When we come to X-rays, which also has high energy content, is used in crystallography. You also used to study fractures and detect forgeries in art and flaws in metals. Then the low energy content waves like the UV radiations is still used in medicine to supply vitamin D, treatment of cancer, mineral analysis, and detecting forgeries. We also have the visible light, which is easily reflected and is the one majorly used in seeing. We see because of visible light. We also have photography. Any photograph taken use visible light, fiber optics, lasers. So those are areas applied. Then we have got the radio waves. So radio waves are categorized in various categories. You have the TV waves, which are long medium wavelength and easily penetrates the atmosphere, so used in communication with the aid of satellite. Then we have the radio waves with the longest wavelength and shortest frequency, which are easily diffracted and are used in radio. Now, the diffraction of TV radio waves. Large wavelengths and low frequency radio waves are easily diffracted. They are also easily detected by receivers in deep valleys and behind hills because they are capable of going round corners. So radio waves of longer wavelength, that is amplitude modulation, they use amplitude modulation, which are easily reflected by ionosphere, so they can transmit sound to long distances. Then short wavelength waves uses frequency modulation, which are transmitted over short distance and directly received by the receivers. Let's talk briefly about the microwaves again. So microwaves are majorly used in cooking, whereby they are produced by the magnetron in microwave ovens. So magnetron produce microwaves at a frequency of about 2500 megahertz, and these waves are directed to a rotating metal shiner which reflects them to different parts of the food. So in the oven, food is placed in a turntable where it absorbs the waves evenly. The waves heat cooks it. So the wire mesh on the door reflects the waves back inside. The device is switched off before opening. So never open a microwave before switching it off. Apart from that, microwaves are also used in radar communication, that is radio detection and ranging, which is used in locating exact position of planes and microwave. And you can also see another like that in exam. Lastly, we can also briefly say that they have varying range of wavelengths, which make the application very wide. For instance, the medium and short wavelength is used in radio transmission signals. Amplitude modulation, radio transmission has longer range because it is reflected by an ionosphere. TV and frequency modulation waves are received at all short distances than the normal radio broadcasts. Very high frequency transmission is used also in TV and FM radios. So it is important we talk of the greenhouse effect because we had touched on the infrared, which has the heating effect. So transparent glass allows visible light of short wavelength radiations emitted by the sun to pass through it. On the other hand, glass cannot transmit the long wave that is reflected by the cooler objects. So heat from the sun. What are some of the hazards of these electromagnetic waves? UV rays and gamma rays carry high energy which damage cells. Then we also have, they can also cause skin burn. They can affect the eyes when absorbed. They have delayed effects of radiation such as cancer, leukemia, and hereditary defects in children. So how are these hazards minimized? That is by minimizing time of exposure, keep a safe distance from radiations, use shielding materials such as lead jackets.